7-2 continued, exponential functions. We're exploring compound interest formula, and we're using E as the base. Okay? E is a number that we will go through today, and we'll talk about how we get there. Okay? I have opened your book space 312, but I'll actually cover all that here. If you want a book to follow along, you can. Let's go ahead and get that information copied down if you haven't done so yet. All right. So let's go ahead and kind of relate this to what you already know. So we know this formula. Y equals a b to the x. Usually use lowercase. Sorry about that. But if we're relating these things, y corresponds to what? A. A corresponds to P. Okay, now note that this A and this A are not the same thing. This stands for amount in our account, our output, after we've done all this stuff to our input. Okay? B stands for our base. This right here is our B, that whole thing. And then X is that guy right there, the n to the t, or nt power. Okay, so the amount in our account is equal to the principal times the quantity 1 plus r over n times, or to the nt power. All right, that is our compound interest formula. The goal for you today, you'll have 3 formulas when you're done. 1 right here, 2 right here, and then you'll have a third. The goal for you will be to figure out when to use each of those formulas. That's our plan. Okay, so here's our compound interest formula. How many have a bank account? Okay, now let's say bank accounts generally give you options. Okay, so let's say we walk into our bank account and say, hey, I want to invest some money. And the money I want to invest is, say, $100. Okay, I want to invest $100, and that $100, as I invest it, could be compounded annually. Okay, so my investment of $100, the bank may compound it annually. And I'm going to use a rate that would be an amazing rate if you got it at a bank for like savings account. It would be an awesome rate. You should take it. But just for the purpose of what we're doing here, this rate really isn't realistic. But I'm going to use 10%. That would be a great rate. Okay, yeah, seriously. Okay, $100 at 10% annually. That, once again, is not realistic. You're more around 2-3%. Okay? But just so I can use 10%, make it a little easier, it'll help with the problem. Okay? At 10%. So that would mean that the cash I have, if we call this X and Y, and think of X as time, and think of Y as amount or cash, okay? The $100 that I have on day 0, before I walk in, okay, will change after a whole year, after 365 days. That amount is going to change. Until the 365-day mark, it stays the same. You have $100 in there until the 365th day. At that point, you will then have how much? 110. You get 100% of your investment plus, so 100% as a decimal, if you think of that, that's 100% is equal to 1 in decimal form. You get 100% of your investment plus what? 10%. 10%, which we know as, okay, 0.1. All right, so I'm going to get rid of that percent now. So let's call that 0.1, 0.10, same thing. That's our 10%. So 100% plus 10% is 110%, which we know as 1.1 as a decimal. So another way to think of this, you probably would want to write 0.1. So 1.1. That's our rate. If I take and multiply my $100 by 1.1, my total is now going to be 110 bucks. All right, that's how I get that. So after 365 days, I have 110 bucks. Now, most of you are like, dude, you made that way too hard. You just take 10%, add it to 100%, and you get 110 bucks. Okay, you're right. I made it pretty hard because the next example is I'm taking my 100% or my $100 and I'm going at 10%, but I am now compounding it semi-annually. Semi-annually. Annually means once. Semi-annually means twice a year. Okay? So that if we follow that same guideline there of time and cash, you'll know why we start changing the variables rather than just using XY. Maybe we use T and M for money or something. Okay? The money I had from my grandma or something, $100 on day 0. Actually, do I have to keep it in 365 days to earn anything? No. How many days? 182? And a half? All right, 182 and a half days. Halfway through the 182nd day, you are going to earn some money. Okay? You're going to get your original amount, which is what percent? 100%, or 1 in decimal form. Plus, are you getting 10%?
Yes.
No. You get 10% annually. Maybe I didn't make that clear enough. That should be annually. There we go. That means halfway through the year, what percent am I getting? 5%. That's just logic, right? We get 5%. So really what you're doing is you're taking your 10% or your 0.1, your 0.1, and dividing it by 2. Okay? Where's the 2 come from? Yeah, semi-annually. Divide by 2. And you multiply all that by 100. So really you're going 1.05 times 100, which gives you $105. Everyone agree? So on the 182nd, or halfway through the 182nd day, you get $105. You're like, score, man, I made $5. Woohoo! Yeah. When's it going to compound again?
182 days.
Yep. On the 365th day, 182 and a half days later, it's going to compound again. You get probably the same rate, right? 1 plus 0.1 divided by 2. So 1.05 of what? 105. Okay? Now, you get a percent of your capitalized. Okay? You now have principal and interest that you're earning interest on. That's good. You like that. It's compounding. Okay? How much is that? $110.25. So, by going with the bank that gives you semi-annual interest, you get 110.25 versus the bank that goes annually gives you 110. You earned an extra quarter. Now you're like, well, it's a quarter. Well, if this isn't $100, but it's $1,000 or $100,000 or your retirement account. Okay, maybe you have $500,000 sitting in there or $1 million sitting in there, and you're earning interest on it. It means a lot. Okay, it's a big deal. All right, well, let's say we don't go semi-annually. Let's go with this other one called quarterly. Quarterly. Quarterly is how many times?
4 times.
4 times. Okay, so we're still at 100 at 10% annually. But this bank that you have found is going, hey, dude, we'll do it quarterly. So you have your X, you have your Y, which is our time, and our cash. At day 0, we're at 100. Day what? Go ahead and figure it out right now on your paper what it would be for the quarterly. How many times you compound, when you compound, and what that money would be worth at that point. Go for it. Okay, for those that are struggling, help me out here. If semi-annually is 182.5, what's my first compounding? 91.25. So a quarter of the way through the first or the 91st day. What would be the third? 217? 273.75. Thank you. Okay. So those are our quarters. We just divide 365 by 4 and by 2 by 3. Okay? Still getting 100% plus 10% divided by 4. Or reality is that reduces to 1.025 times 100, our original amount. So on day 91, a quarter of the way through the 91st day, we would have $102.50 in our account. How many got that for your first one? Okay, $102, man, 50 cents. That's good. Next one, I'm going to use my same rate. Okay, so but I'm using $102.50 now, multiplying it by 1.025 to get. Anyone got that one? Jody? $105.01.
It was like
0.625.
Yeah.
So it'd be 7 cents or 6 cents?
6
Okay.
and a quarter of a cent.
All right. You didn't get
I
that?
did.
Wait, hold on.
Anyone else get that? Eli guy, a couple of you? Okay. So here we now have $105.06
Oh, I know this one.
times 1.025 to give us,
Oh, I got this.
Yeah.
107 and 68, 9, 65. 68 cents. Or 69 cents.
69.
I
Okay.
doubt they're going to round. Would they round?
All right.
Would they round it?
Maybe, but you probably would have calculated here, so you're going to cut all that off. We'll round the nearest penny.
I know, but would the bank round it?
They might. Depends on the bank. I would assume they would. They wouldn't cheat you out of your money. They may just have that calculation. They may not round off exactly like that. But I would assume they're going to round up there. Maybe not. You might have to do the math on that.
Maybe they're mean.
Okay, what's the next? 107.69 times 1.025 equals, Yeah.
110,
and what? 38 cents. Dude, how much more did we make?
38
cents.
13 cents
Oh.
more than when we went semi-annually.
Holy cow.
Seriously, man. Now, if we went quarterly, or not quarterly, if we went monthly, do you think we would earn 13 more cents?
No.
Probably not. Eventually, we don't earn quite as much, right? The difference isn't there, and we're actually going to see that in our next example. Okay, any question how the compound interest works there? Nick?
So when you first start, 1.025 would be the rate you go up by.
Yeah, so let's apply that to our formula real quick. We have A equals P times 1 plus our rate, 0. I should just put R here for now. Okay, our rate over N divided by, or times N to the T power, right? So here's our principal. In this case, that was in our example, what was that?
The 100.
No, that was originally our 100, right? It kept changing, but it was our 100. All right, so if we just did our first one here, from here to here, okay, it would be 100 plus or times our 1. Well, our 1 happened to be that one, the 100% of our 100, plus our rate divided by N. So 10 divided by, our rate is 0.1. Notice our rate's in decimal form. And N stands for the number of times we're compounding. In this case, 4. All to the, this is the part we did not do. This would be to the 4 times, how many years? We calculated it for how many? 1 year. Okay, so really we calculated for 1 year. So really if I wanted this number right here, I could do that math right there. I wouldn't have to do that. That's the purpose of the compound interest formula, is that I don't have to keep doing that every time. Like if I say, okay, what if I kept it in for 2 years? Well, now you change that to 2. What if I kept it in for 20 years? Now you change it to 20. Okay? That's how the formula works. All right. Anyone checking me? Right? And did it work?
Yep.
Yes. Right. I was worried. All right. Very good. Okay. In reality, guys, I have, like, at home when I do my finances, I have this huge Excel spreadsheet. I put in my whatever debt I have, or whatever account or investments I have. I know my rate. I know when it's compounded. Those are variables I put in. I have this big formula in there, and it calculates it for me. I have it done out by the month, so I know where I'm at monthly, depending upon it. Why? Because that's what I do. I like it. Some people aren't that picky about it.
Math is fun.
Math is fun.
I
Yes,
love
I love math. Very good. All right. Next page. Oh, yes, you're welcome. So, yes, but wait, there's more. Okay? All right. What I'd like you to do, taking a look at this, we're going to try to go through this as a class. Now, it's up to you if you copy this down. However, my purpose isn't for you to have it copied down. My purpose is for us to complete it as a class. All right, last period they had to copy it down because they couldn't work on it as a class, unfortunately. But after this, I mean, they were flying. They were awesome. But that's because they had to copy the table down, I think. I don't know if they liked it. So, here's what we've got. We're going to apply kind of like we just talked through here. If something's compounded semi-annually, I have $1,000 this time, and I'm compounding it semi-annually, okay, at 10%. How do I know it's 10%?
0.01.
0.1. You can go ahead and grab it out of the tray there. 0.1, right? So this is 10%. How is this changing right here? How is this semi-annually changing it? Go ahead and tell your neighbor. Everyone make sure your neighbor tells you something. Olivia, if you need help, make sure you ask. Okay. What do we got?
It's divided by 2 instead of 1.
Yeah, it's divided by 2 instead of 1, right? Because the n tells you how many times you're compounding. This is n, so this becomes 2. And then I have to the second. Yeah, the 2 times 1 power, right? Number of years is 1. Number of compounding times is 2. So 2 times 1 are the second. We're going to calculate that out. Someone got it for me?
Go, Lucas, go.
1, 1, what? 02.5. Okay, very good. Here's what we got. You guys are going to finish this table for me. So what we're going with this L right here, this L, actually you guys right here, chunk. These
The L.
1, 2, 3, 4, 5 tables. You guys have quarterly. Figure it out. You guys 1, 2, 3 tables. You have monthly. 1, 2. You guys have daily. 1. And you 2 guys in the back have hourly. You 3 have by minute. Okay? Figure it out. Figure out the amounts. Pick one person to be the expert. Quarterly, what do we have?
1,103.
1,103.81. So this is 1,000 times 1 plus 0.1 over 4 to the 4 times 1. Okay, or just fourth. Okay. And monthly, we have 1,000 times 1 plus 0.1 over 12 to the 12 times 1. And we get? $1,104.71. All right, very good. Daily, we get 1,000, 1 plus 0.1 over 365 to the 365 times 1, or what do we get?
1,105.16.
Dude, we're not going up by as much anymore. Not even $1 difference. Not even 50. Man, we're getting ripped. All right. Okay, 1,000. 1 plus 0.1 over, holy moly, 8760 times 1 is?
I got 1,105.17.
One more penny?
That's a lot. Hey, that's more than one
All
less
right.
penny.
That's better. Yeah, that's right. A penny saved is a penny earned. That's right. All right. Okay, 5,256 times 1 is the exact same? Yeah, what a rip, man. Yeah, it didn't even make anything. That's with 1,000, maybe $1 million you would. Okay, the reason is these two differ, but they probably differ way out here. Okay, where we don't, I mean, in our currency system, we only got out to the 100th.
So if you had like $1 million by minute would be good.
Yeah, it'd be better. Yeah, I like that. Okay, So the question is, what happens when n gets greater? Well, as n gets greater, what happens to our value of a?
It goes up.
It increases. As the number of times we compounded got greater, it increases. What do you think would happen if our principal changed?
We'd be able to go.
Yeah, obviously our amount would change, but we'd see more of a change in these values as well. Now, it wouldn't be, it'd still eventually level off, okay, where we wouldn't see it, okay? What happens if the number of years change? It goes up as well, yeah. You get more, your amount increases because you're compounding more times, right? If here we're only compounding 4 times, but if we change that to 2, then all of a sudden we're compounding 8 times. But all those would change to 2s then. Okay, well, what ends up happening as you keep compounding? We went by the minute. We could go by the second. In nature, things, if you think about decay, like if you have a leaf on the ground and you just leave it out there, it's decaying. Now, if you just sit there and stare at it all day, you'd be like, dude, nothing happened. Okay, but if you stared at it for a week, the whole week, you'd probably be cold and you'd probably start seeing things happening. Okay, decay continuously happens. It doesn't go semi-annually. It's like, oh, time to decay today. All right. Oh, done. All right. Decay again in 6 months, right? Okay, it's decaying continually. So what happens in science is you start seeing continuous growth or continuous decay, depending upon what we're dealing with. It happens naturally. Okay? When you guys study physics and calculus, in your advanced math and science classes, you're going to start seeing continuous growth, continuous decay, and we use a letter called E for that. Okay? And E has a special value to it, just like pi does. Okay, so what I want you to do is taking a look at this. We're going to use our same, we can't use same groups. I'll make some new groups up. But we're going to take and look at interest if it's compounded continuously. Okay, so what I want you to do, we're going to use this formula right here. Y equals 1 plus 1 over n all to the nth power. Okay? So really what we're doing is we're making our principal 1, we're making our rate 1, and we're making our t equal 1. So we're taking and we're making it so that those things, we're kind of ignoring principal rate and the number of years and trying to focus in just by looking at the influence of the number of compounding periods in. So by making everything else, we're looking at just the influence of the number of compounding periods. And we're going to change the number of compounding periods. We're going to go 2, then 8, so we're multiplying it by 4 every time in this case. But we're going to just continually making it bigger. All right? In fact, we'll even at, because we have so many cool people here, we'll go even at 1024. Okay? We didn't get to do that last class. You guys are so special. You get to do 1024. Okay? So this group right here, you guys over there, you 3, get to the 2nd power. The previous group, the one before that, you get to the 8th power. I can't remember who it was. The group before that, raise your hand if you have the 8th power. Yes, yes. Come on, man. Yes. Yes, okay. Raise your hand to the 32nd power. Who was the group prior? That's you guys. Yes, raise your hand. Yes. Okay, 128th power. Yes, you 3 can have 128th as well as you guys can have 128th as well. Okay, 512. You, that whole row. And right here, 1024. Okay, ready, go. Okay, 2nd power, what did we get? 2.25. 8th power, what did we get? So we're going to put 8 in for n. 2.57, well done. Okay, 32nd power. 2.67. 128th power. 2.71. 512th power. 2.72. 1024th? 2.72. How about, let's do the 2.048. Hey, that's a game.
Hey, I beat it.
2.72. All right, let's go 10,000th.
many?
2.7.
2.72.
Two.
Huh. Well, what do you think will happen as n continues to increase?
Eventually it reached 2.7.
Yeah, eventually we just get to 2.72. If you find the button labeled E on your calculator, I believe it's second. Everyone look for it. Second something.
I found it.
Second what?
Second division.
Second division, yes.
Second division. Or the one that says e to the x, which is second ln on your calculator. Okay, you find the value e. Go ahead and push e, second division, and enter.
2.7.
That is 2.72. That is what e is. That's the rounded value of e, 2.72. So e, like when I'm around my house, I go e. I'm just going to start, hey, 2.72. Come on. You get the joke, man.
I did get the joke. It's funny.
All right,
It's a very
2.72. That is what e is. It's just like 3.14, right? So well, I mean, it's not just like it, but you know, pi is 3.14. E is 2.72. You'll use it in calculus. You can't do calculus without it. You'll use it in physics. How many of you planning on doing physics? Yeah. Dude, physics was my favorite science class. It was my highest grade in high school and then my highest grade in college out of all my classes ever. Amazingly fun. Physics is so fun. Just saying. If you don't like it, don't blame me. All right. A equals PERT. That is if we are continuously compounding interest. Or if we're continuously, in this case, that's continuous compound interest. But you use E if if something's continuously compounding. Decay or growth. If it's going continuously, it's not stopping, you'll use E. This is for our continuous compound interest. So let's make sure we understand. A is still amount. What's P?
Principal.
Principal. Everyone tell your neighbor what principal means, not snow.
Like the initial email.
Yeah.
Okay, principal is what?
I've got the best of it.
Yes, that's our initial, our starting amount. What's E? Good, very good. It's approximately 2.72. What's R? Rate of interest. It's our rate. And it's our rate in decimal form. Make a note of that. That is the most common error on the test. Decimal form. Make sure you put it in decimal form. Huge. Oh, that's, you guys can tell me it's really blurry. I'm sorry. Okay.
Really.
Decimal form. Huge mistake made on our test. What's T? Time. Time in what?
Years.
Time in years. All right. Very good. Time in years. How many have ever heard of PERT shampoo? PERT. That used to be like a popular shampoo. So this used to be called the shampoo formula. Okay. PERT. P-E-R-T. PERT. Okay. All right. Very good. Any questions? Look at page 20 or number 21 on example 3 of your assignment.
You know, it's an irritating word.
I want you to go ahead and try number 21.
Wait, wouldn't it be 1.05 instead of just 0.1?
Yeah.
No, it's
Hey, here we go. Let's see if we got it. A equals PERT. What is P?
1,000.
1,000. What is E?
E.
Yeah, we're just going to call it E. We're not going to round it. Okay? You don't want to round it. We're just say E. Here is the key. What is R?
0.05.
It's 0.05. It is not 5. It is not 1.05. The two most common errors. Guys, I'm telling you, tomorrow we're going to start, or Thursday we're starting logs in here. And at that point, your mind is going to completely forget about this because logs get so difficult at times for you. Make a big note that this is 0.05. Maybe even say to yourself, it is not 1.05 and it is not 5. Okay? It is 0.05. It is your rate. It's not your rate plus 1. It's just your rate. Okay? If you made that mistake, that is the common error, man. That rate up there. And then, what's T? 4. Okay? So when we multiply it out, we get
$1,221.40.
21 and 40?
Yep.
You.
All right. Very good. Now, start thinking through it logically. I mean, if it 5% compounded annually, that would be, I mean, just simple interest. Okay? 5% compounded annually, you get 5% of that. What is 5%? 1,000 divided by 20. 100 divided by 20.
Oh,
Five.
5.
I literally just said 50.
Okay, 50. And 4 years, that's how much?
Okay, 50 times 4.
Okay, guys, I'm trying to get you, hey, really quick, like the way you check these, because you're like, well, I could just put it in my calculator again. I mean, okay, well, you got to know 5%, there are 5 20s and 100, right?
You.
Okay, so you're saying what is 1,000 divided by 20? Well, 1,000 divided by 10 is 100. So half of that is 50. There, okay, so 50. Simple interest, that's just saying this is what I get. Simple interest is just I get $50 a year. $50 a year for 4 years is how much? 200. So just simple interest wise, $50 a year at 4 years is 200. That's $1,200. Compounded interest, yeah, I could probably get an extra 21 out of that. Okay, at least you're kind of in the ballpark. That's a way of figuring out. If you got 10,000 here, and you did simple interest and got 1,200, then you probably have a problem. You may want to recalculate it. Okay, did anyone put a 1 right here to begin with and get a different number? What'd you get, Sam?
66,686.3.
Okay, guys. Now you may laugh, but I will tell you how many very bright students are gonna from this class will do that on their test. Think through it logically when you're done. Okay, so 66,000. Obviously, if we did a quick rough estimate, we go, oh, that might not be right. Okay. All right. Any questions there? Anyone put 5%? Just like the 5 versus 0.05? Okay. Very good. Your assignment. I'll give you that. Your assignment is going to be example side 21 through 24. So mark it down. Example side 21 through 24. Mixed side 1 through 9. I kind of cut down the assignment a bit just because I think we're going to be getting a lot of review on it tomorrow. If you recall at the beginning of class, I said one of our goals is to know when to use this one versus when to use this one. Oops, should make that an A if I'm doing this exactly. Okay, A equals P times 1 plus N over, or excuse me, R over N to the NT versus when to use this one. So, talk it through with your neighbors. Maybe even focus on these two. When to use those two. What are the keys that will help you remembering? Okay, volunteer. Anyone want to give me some insight on when to use one of these? Jordan?
You use the bottom one when it's like continuously, and the middle one when it's just compounded, but like over, like not continuously. I don't know how to say that better. And you use the top one when it's like just simple interest and there's no compounding.
Okay, keyword on this one. Very good. Keyword here is continuously. Okay? On this one, you guys, I would write it down. This one might be semi-annual. You might see quarterly. You might see monthly. Those are key terms. You could actually use it for annually, but really annually is up here. Okay, but you could use it if you wanted to use it for annually, you could. Those two things right here, anytime you see the word compound interest or compounding, okay, you've got to ask yourself, okay, it's compound. It's dropped me into one of these two. Is it continuous? Then it's this one. If it's not continuous, then it's this one. So compound brings me to these two. If it's continuous, it's down here. If it's not continuous, it's here. This is just your exponential. Okay? Otherwise, it's here. All others are there. Okay, I'm going to leave you that to copy down.